You're much welcome at Medical Sciences by Naftali Mumza. And in this video, I want to discuss about antigen-antibody reactions. In the previous videos, we have looked at antibodies, we have looked at antigens. So in this session, we want to see how antigens interact with antibodies to produce the reaction. And we have said that if we have an antigen, an antibody, and we have seen antibody being Y-shaped with the antigen binding site, which is known as the paratope. And if I'm to zoom it, if this is the paratope, it has the CDR region or complementarity determinant region where the antigen binds. So the antigen should be complementary to the CDR region or the paratope region of the antibody. So this is the antigen, and this is the antibody. So in this session, we want to zero on these reactions whereby the epitope of the antigen interacts with the paratope of the antibody to form antibody-antigen reactions. And we are going to discuss different types of antigen-antibody reactions. But before we start, we always remind you to hit the subscription button. If you haven't subscribed, like the video and share to others. So before we begin talking about antigen-antibody reactions, we needed to know these two terms, what we know as affinity and avidity. And affinity is having much love. So the much love of the antigen to bind to the paratope of the antibody is what we know as affinity. So affinity is the strength, or it is the ability, the strength of binding. So the strength or the ability of an antigen to bind to an antibody is what we know as affinity, whereas avidity, in summary, it is affinity. You have affinity plus valence. Because in the previous video we have seen antigens have different epitopes. They can have one which is monovalent, two divalent, and more than two multivalent. So if you gather the strength between each epitope interacting with the paratope and you come up with the total, is what we know as avidity. So avidity is the total strength. We see affinity being the strength, but this one is the total strength. If an antigen has more than one epitope, and the affinity for different epitopes, when you add up them together, you come up with avidity. So you should know the difference between affinity and avidity. After looking at that, we are going to see different antigen-antibody reactions which depend on the foreignness, on the cross-reactivity. They depend on the temperature of the media and the pH. We are going to see there are major 6 reactions, that is precipitation reaction. We shall talk about agglutination tests or reactions, fluctuation reactions. Then we shall talk about complement activation reactions. We shall look at neutralization and fluorescence. And a very quick overview of each. We shall tell you that under precipitation, this one they use soluble. They interact with the soluble antigens, and these antigens must be divalent or multivalent. And with these soluble antigens react with antibodies to form precipitates. And these precipitates, they have ability to sediment. This one gives us a difference between precipitation and fluctuation, whereby fluctuations, it also involves the soluble antibodies, and these soluble antigens, they react with antibodies to form a precipitate which is always suspended in the liquid. And this one will give us what we know as the fructose, because they are suspended in the liquid. Whereas the precipitations, for them, they form a sediment. This one is the form fructose suspended in the liquid. which is the difference between precipitation and flocculation. Then agglutination, we shall see IgM being involved to form visible clump, to form visible clumping. So we shall see different agglutination tests performed under this, but this one involves antibodies, especially IgM and to a lesser extent IgG, which binds to different epitopes of the antigen to form visible clamping, or what is known as agglutination. Then complement activation, here we shall look at a test like complement fixation test, which relies on ability of antibodies to fix the complement. Here the ability, so we shall say test as the complement fixation test. Then under neutralization, we shall see how different antibodies like IgG and IgM have ability to neutralize pathogens like bacteria. And after neutralizing them, we utilize a compound known as hemolysin. And whenever we have hemolysin and we add red cells, we shall always look for cell lysis. And when there is no cell lysis, we shall be able to confirm if a test is positive or negative. So this one involves use of hemolysin. This one depends on the antibodies to fix the complement. Then fluorescence, here it is where we shall see the use of fluorescent dyes, whereby we shall use the fluorescent dyes like FITIS and rhodamine, so that we can visualize the different components. And under fluorescence tests, we shall see like ELISA, radioimmunoassay, that is the RIA, and all other fluorescent tests shall be performed under this. So this is the quick overview of antigen-antibody reaction, which depends on the temperature. They depend on the pH of the media. They depend on the foreignness of the antigen and cross-reactivity or presence of other foreign materials. So in this session, we want to zero on precipitation reactions. Then in other videos, we shall look at this one by one. So precipitation, which we are beginning as number one, is an antibody-antigen reaction. It is an antigen-antibody reaction, which is characterized by soluble antigens. And these soluble antigens interact with antibodies to form precipitate, and this precipitate forms or sediment, has ability to sediment. And before sedimentation is formed, this one works under the conditions which must happen is soluble antigen should be at a specific pH and at the specific temperature to form sediments as a precipitate. And it involves soluble antigens which must be divalent or multivalent so that we can be able to see the precipitates as a sediment. And this precipitation method, it can be either quantitative or qualitative. And here we want to utilize zone phenomenon, which is an experiment performed under quantitative precipitation method, whereby in this method we shall get different tubes, and these different tubes we shall put increasing amounts of antigen. If here we put 2 antigens, we are going to put different amounts of antigen, 2, 4, we shall put 8, we shall put 16 and 32. So after putting in different tubes increasing amounts of antigen, we come and add the same amount of antibody. So all of them we add 4. Maybe let me say we are adding 4 antibodies. So we add in each, and after adding we mix, and then we read the precipitation or sedimentation. Afterwards we plot the curve, and after plotting the curve, by looking at the reaction in different tubes, we shall come up with different zones. What is bringing the heading known as zone phenomenon, whereby we shall have If it is on the x-axis, we have antigens which is varying amounts vis-a-vis the amount of precipitate formed. We shall come up with prozone phenomenon, prozone. We shall come up with a zone of equivalence and post-zone. And we are going to describe one by one. Whereby under prozonic phenomenon, this one is known as area of antibody excess. Because in tube 1 we put 2 amounts of antigen and 4 amounts of antibody, we are going to see that if this is antibodies, 4 of them, and we put only 2, we are going to see some are going to remain not bound to antigen. So we find only 2 binding, and these 2, they are remaining in excess. So that's why we see prozone phenomenon, or what we call the prozone, being the zone of antibody excess. Because antigens are little and antibodies are much, and this one can result into what we call false negative. Can result into what we call false negative reactions. Why? Because some antibodies are remaining not bound to the antigen to form antigen-antibody reaction. Here there is no lattice formation and there is no cross-linkage. And because there is no cross-linkage, there will be no visible precipitants. There will be no visible precipitants. That is under prozone. So this one, it enables us to know that in case we add a little amount of antigen, in rapid diagnostic kits, we can easily get what we call false negative. Then under zone of equivalence, here there is equal proportions. Here we see equal proportions. The antigen and the antibody are equal. And because they are equal, we see there is lattice formation and cross-linkage occurs because they are of the same number. And when the cross-linkage occurs, it results in 2 visible precipitates. There is visible precipitates formed, and this is what we know as zone of equivalence, in that if we have 4 antibodies, even the antigens are 4, that is in tube 2. In tube 2, whereby we have the same amount of antigen and antibody. So because they are of the same number, there is a lattice formation and cross-linkage resulting into visible precipitation. So this one results into visible precipitation because there is equal proportion of antigen and antibody. Then the last zone is known as post-zone, and under post-zone, this is an area of antigen excess. Here, we are going to see if we have only 4 antibodies. We have only 4 antibodies, the antigens are more. So we shall find all antibodies will bind to the antigen, but more antigens will remain unbound, free. That's why we are calling it the zone of antigen excess. Zone of antigen excess. So the proportion of antigen to the antibody is greater. We see antigens being greater than antibody. And this one will result to no formation. There is no visible precipitation. Visible precipitation will not occur because there will be no cross-linkage and there will be no lattice formation. And because there is no lattice formation, no visible precipitation, because the antigens, majority of them are not getting where to bind to the paratopes, and then there is no visible precipitation. That is the post-zone phenomenon. So under the zone phenomenon curve, after giving different varying strength of antigen, then adding the same amount of antibody, after plotting the curve, we have seen we come up with the 3 zones. That is the prozone, which is known as area of antibody excess, then zone of equivalence, whereby it is a zone where antigen and antibody are equal. Then the third one is post zone, whereby this post zone is whereby it is a zone of antigen excess. And we have seen prozone and post-zone, there is no visible precipitation because of varying numbers. Here we have antibody excess, here we have antigen excess. And this one, you can ask yourself, why do we need to know it? This one can enable us to standardize toxins and antitoxins. And even it has helped us in lab to those manufacturers who do rapid diagnostic kits to standardize the amount of antigen or antibody to add to the rapid diagnostic kit. So this one is the applicability of this zone phenomenon, or is to know how much of the sample to be added on the test kit, or how much of the serum is to be added. So this is what we can discuss under zone phenomenon. In the other videos, we shall also look at the agglutination on its own. We shall look at complement fixation and the neutralization tests. Thank you so much for learning with us, and may the good Lord bless you.